All right, let's go ahead and look at some examples from 2.6. We did number 6 already in the previous lecture video. Let's take a look at number 3. And this will just kind of help us get an idea of what we're talking about with these slopes of tangent lines. And so we have a graph here that we're looking at. And on this graph there are 5 points labeled A, B, C, D, and E. We're supposed to consider the slope of the given curve at each of the 5 points and list the 5 points in decreasing order and explain your reasoning. So decreasing order. So we want the steepest slope first. So basically we're looking for where is the function the steepest. And it looks to me like it's the steepest in the positive direction here. It will increase as we move from left to right at D. The line tangent there is the steepest. If you look at the line tangent here at E, it's not as steep. So I would say D is the most steep, E is the second most steep in positive direction. Now we do have a slope of 0 here at C, looks like, where the thing turns. It looks like our slope of the line tangent here is 0, so C would be next. And then we have two negative slopes, one here at A and one here at B, and it looks like B is steeper in the negative direction than A is. So I would list A next and then B as the last one, the steepest in the negative direction. So in decreasing order, I mean if we were to assign actual values here, for example, maybe this is a slope of 5, a slope of 3, a slope of 0, a slope of negative 5, and a slope of negative 3. So if you look at those, what we'd have, and I'm just guessing here on those slopes, I don't have any reason to believe that's exactly what they are. I know C is actually 0, A, negative 3, negative 5. So these numbers are decreasing as we move, as we list them there. Let's take a look at another problem. How about number 11? We're asked to find in part A the slope of the tangent to the curve y equals 3 plus 4x squared minus 2x cubed at the point where x is equal to a. And so let's go ahead and use our definition that the slope, m, is equal to the limit as h approaches 0 of f of a plus h minus f of a all divided by h. Now, if we put a plus h into our function, we get 3 plus 4 times the quantity of a plus h squared minus 2 times the quantity of a plus h cubed minus f of a, which is going to be 3 plus 4a squared plus 2, minus 2a cubed. So we're running out of room here. Minus 2a cubed. All of that divided by h. Now, what is this going to give us? This is going to be the limit. The limit here as h approaches 0. As h approaches 0 of 3 plus 4 times, if I square out a plus h, I get a squared plus 2ah plus h squared, minus 2 times, let's see, I have a plus h cubed. Let's square it first. A squared plus 2ah plus h squared times a plus h. Now, distributing the negative through this second f of a, we have minus 3 minus 4a squared. Minus a minus makes it a plus 2a cubed, all over h. This becomes then the limit as h approaches 0 of 3 plus, let's distribute this 4 here, 4a squared plus 8ah plus 4h squared. We have one more multiplication to do here, so minus 2 times, we take the a through, we get a cubed plus 2a squared h plus ah squared. Take the h through that quantity, we get a squared h plus 2ah squared plus h cubed minus 3 minus 4a squared plus 2a cubed, all divided by h. So this then becomes the limit as h approaches 0 of 3 plus 4a squared plus 8ah plus 4h squared minus 2a cubed, distributing the negative 2 through here, minus 4a squared h minus 2ah squared minus 2a squared h minus 4ah squared minus 2h cubed minus 3 minus 4a squared plus 2a cubed, all over h. Alright, things are a little bit ugly here, but hang in there. It's not going to be too bad. Let's see what we can get rid of. We have a positive 3 and a negative 3. We have a positive 4a squared and a negative 4a squared. We have a negative 2a cubed and a positive 2a cubed. So we're left with then the limit as h approaches 0 of, let's see, we have 8ah. Any other ah's? No, we have 8ah. So we've used that up. How about 4h squared? Any other h squared terms? No, so plus 4h squared, we've used that up. Negative 4a squared h. Here's minus 2a squared h. So that's a total of minus 6a squared h. And then we got a 2ah squared and a negative 4ah squared. So that's a negative 6ah squared. And finally a negative 2h cubed. All of that divided by h. And so now dividing each of these individual terms in the numerator by h, we have the limit as h approaches 0 of 8a plus 4h minus 6ah minus 6, this one is just 6a squared, no h there, 6a squared minus 6ah minus 2h squared. And again, we divided every term by h, so we don't have an h in our denominator anymore. And now this function that we have left, which is equivalent to the original function, so it has the same limit as h approaches 0. This has 0 in its domain, so it's continuous there as a polynomial. Plugging 0 in for h, what do we get? 8a minus 6a squared, and that's it. 8a minus 6a squared. And so now we can find in part b, for example, the slope of the line tangent at, say, 1, 5. Well, here, a is equal to 1. And so our slope is equal to 8 times 1 minus 6 times 1 squared. That's 8 minus 6 is equal to 2. And so we have the slope there. We could find the equation of the line at that point by looking at y equals mx plus b. So y, which is 5, is equal to our slope, which is 2, times x, which is 1, plus b. That means that b has to equal 3. And so the equation of the line tangent to the curve that we had originally of y equals 3 plus 4x squared minus 2x cubed at the point 1, 5 is going to be y equals, let's see, what was our slope? Slope here was 2x plus b. So 2x plus 3. So you can see these get a little bit messy with the limits there, but if you just stick with it, everything's going to get to the point where you can cancel out. You should just have h terms left. I mean, that's what you're looking for here. We had this big mess that we went through, but notice what happened. Everything that didn't have an h in it, like the 3, the 4a squared, the 2a cubed, those all canceled each other out. And we were left only with terms that had at least one h involved. And so that means when we divide each of those terms by h, we were able to do that and get rid of this h in the denominator, and then we could go ahead and plug 0 in for h to get the equation that'll give us the slope of the line tangent at any point on our function where x is equal to a. Alright, let's go ahead and look at another problem then. How about number 18? So in this particular problem, we are given the height of an arrow shot upward on the moon that has a velocity of 58 meters per second. So its height after time t is given by 58t minus 0.83 t squared. So this is one of those problems where we're given a position function. We're given how high off the ground the arrow is at any time t. And so that means that the slope of the line tangent is going to give us the instantaneous velocity of that arrow at any particular time t. Now, the problem you're going to have in your homework is just going to ask you what velocity the arrow hits the moon. Well, in order to find the velocity, you're going to have to find the limit as h approaches 0 of f of a plus h minus f of a divided by h. But now, what are you going to put in for a for the value when the arrow hits the moon? Well, what's going to be true? When the arrow hits the moon, that means it comes back down to, well, not to Earth, comes back down to the moon. The h, the height, is going to be 0. So you're solving this equation. The height equals 0 equals 58t minus 0.83t squared. Factoring out a t here, we get t times a quantity of 58 minus 0.83t. So either t is equal to 0 makes this true, and that means at time t equals 0, the arrow was at the level of the moon, or 58 minus 0.83t equals 0. If we solve this for t, just put that in your calculator, which is going to amount to dividing 58 by 0.83. We get t to be approximately 69.88. And this is going to be, looks like, in seconds. So approximately 70 seconds after the arrow is shot up, it hits the moon. So now it's left to find the instantaneous velocity at that point. Well, the instantaneous velocity v at any point A is going to be, well, it's going to be the limit as h approaches 0 of f, well, that's the case, it's h of a plus t, no, how about a plus h minus h of a, all divided by h. And so that's the limit that we want to find out. And then, once we do that, we will plug the 69.88 in for a. So let's go ahead and do this. So the velocity, instantaneous velocity, is going to be the limit as h approaches 0. Now, if we put a plus h into our function, 58t minus 0.83t squared, we have 58 times a plus h minus 0.83 times a plus h quantity squared minus h of a. Make sure when you're subtracting the original function, you're subtracting this whole quantity off. So minus the quantity of 58 times a minus 0.83 a squared. So we just put the a in for t, put the a plus h in for t here, and put the a in for t here, all divided by h. This is equal then to the limit as h approaches 0 of, let's see, 58a plus 58h minus 0.83 times, if I square out a plus h, we have a plus h times a plus h, so that's a squared plus 2ah plus h squared. And then distributing this negative here, we get minus a 58a, and minus a minus is a plus 0.83 a squared. All that divided by h. Alright, so we're getting close here. We have the limit as h approaches 0 of, well, we got 58a plus 58h minus 0.83a squared minus 0.83 times 2, which is going to be 1.66 ah minus 0.83h squared minus 58a plus 0.83a squared, all of that divided by h. Okay, and then let's see, what do we lose here? Well, positive and a negative 58a. Remember, we should get rid of all the terms that don't have an h in them. Here's a negative 0.83a squared and a positive 0.83a squared. Everything else should have an h, and it does. So we have then the limit as h approaches 0 of 58h minus 1.66ah minus 0.83h squared, all of that divided by h. Now dividing each term here by h, what do we get? We get the limit as h approaches 0 of 58 minus 1.66a minus 0.83 h. And now plugging 0 in for this, plugging 0 in for h, which we can do now because the function is defined and continuous at h equals 0, gives me 58 minus 1.66a. So now we are ready to find the instantaneous velocity when the arrow hits the moon, which remember was at 69.9 seconds. So how fast was the arrow going when it hit the moon? Remember, we found that it hits the moon 69.9 seconds after it's fired up. How did we find that? Well, we said when it hits the moon, the height has to be 0. So we set the function equal to 0, solve for t. We got two possibilities. One was when we first fired the arrow. The other is when the arrow lands 69.9 seconds later. So we're going to plug that into our velocity function, v of 69.9, and this was what we had here. v of a, the velocity at any time a, is equal to 58 minus 1.66 times 69.9. And so we get 58 minus 116.034, and when we do that subtraction, we get approximately negative, well, we get exactly negative 58.034. We get exactly that, and so that's approximately negative 58. Now, what's the unit on that? Well, that's how fast the arrow is traveling. It's negative because it's coming down at that point. That's the reason it's negative. But the unit on that is going to be the unit of the position. Well, the position, remember, was given in, let's see if we look in our book here. Yeah, in meters. So it's going to be meters per the unit of the input of the function, which is second. The unit on these instantaneous rates of change and these tangents is always going to be the unit of the output of the function, which was meters, divided by the unit of the input function, which was seconds. So it's going down at 58 meters per second. That's the velocity at that point when it hits the ground. Good 58 meters per second, moving pretty quick. Alright, I think you should be in pretty good shape to do the rest of your problems based on what we've done here in the videos and on your reading in the book and looking at the examples in your reading. You'll need the password then. And the word that'll get you into the 2.6 homework is perfunctory, which just basically means run-of-the-mill or regular or kind of things that you have to do, but aren't very exciting. Perfunctory is your password for 2.6. Let me know if you have any questions.